When it's time to move to another planet, Mars is right next door. But it's a freeze-dried rock, too cold for life. We could warm it up, but not like this.
Well, we know how to warm up planets. We're demonstrating that we know how to do that right here on Earth, where it's probably not a good idea.
We'll do it the old-fashioned way, with factories and global warming, on purpose. In 100 years, Mars will be warm, wet, and ready for life. It's called terraforming, and it sounds like science fiction. But it may be coming to a planet near you sooner than you think.
That's not something for 500 years in the future. That's us. We're going to Mars.
What would it take to make water flow on a world where the average temperature is 80 below zero? Or turn bare rock and dust into soil where forests could grow? What would it take to terraform Mars? Create a planet more like Earth, where humans could breathe the air? It would cost billions and take hundreds, if not thousands of years to accomplish. But transforming Mars from a barren rock into a living world is not as far-fetched as it may seem. And our long-term survival could depend on it.
If you're a threatened species, which, let's face it, we are, you don't want to all be in one small habitat. You want to be diversified.
Terraforming is already on its way from science fiction to science fact. Here on an 18,500-foot volcano in Mexico called Orizaba. It's a magnet for climbers, adrenaline junkies, and planetary scientists. Chris McKay is one of them, an astrobiologist interested in the possibility of life on other planets. His research takes him to extreme environments all over the world. Places that expose the limits of life on Earth. What draws him to Orizaba are the trees, and in particular, the tree line. At 13,000 feet, it's among the highest in the world, which means these pine trees live right at the edge of what trees can tolerate.
We're trying to understand what is it that sets the tree line. We want to know, why do the trees grow down there, but not here? Clearly it's warmer down there and temperature is the key variable, but something in the forest ecosystem is responding to temperature.
With colleagues from the National University of Mexico, McKay is trying to pin down the minimum requirements of temperature, rainfall, and nutrients that trees need to survive. He hopes that knowledge will get him closer to his real goal, understanding what it would take to grow trees on Mars. At the moment, Mars looks like a bad place to grow anything. 50 million miles farther from the sun than Earth, it's a frozen desert of rock, ice, and dust. And it's been that way for billions of years. It's little more than half the size of Earth, but it has the same land area as all the continents on Earth combined. Intense ultraviolet and cosmic radiation sterilize the surface. Temperatures can range from 200 below zero at the poles to 80 above near the equator. But the carbon dioxide atmosphere is so thin, when ice thaws, it turns straight into vapor, not liquid, leaving the surface bone dry. To bring this hostile world to life would take planetary engineering on an almost inconceivable scale. But McKay believes the potential is there, waiting to be tapped. And the Orizaba volcano is a kind of living laboratory for understanding how it might happen.
Conditions on Mars are like the top of a very high mountain. Imagine a mountain on Earth 100,000 feet high. That's what it would be like on Mars. Very low pressure, very low temperature, high radiation, conditions so harsh that no life form on Earth could survive.
There are no 100,000-foot peaks on Earth, but the 18,500-foot summit of Orizaba is a polar desert like Mars, with a very thin atmosphere and temperatures close to zero. But at lower elevations, the temperature rises as the atmosphere thickens. Bare rock gives way to grassy tundra, and the first signs of life on the surface. Then, abruptly, the tundra gives way to trees, a dramatically more diverse ecosystem. This transition from a barren summit to an alpine forest is the same sequence of change that Mars would go through in the process of terraforming.
So the tree line is the key. We want to understand that transition. We want to know how much do you have to push Mars? How warm do you have to make it before the first forests, before the first trees can grow on Mars?
Terraforming has been a special passion of McKay's throughout a long career as a researcher and scientist on planetary missions. It began with the realization that Mars was not always as hostile to life as it is today. Orbiters have found dried up lake beds, river channels, and deltas all over the planet. Clues to an early Mars that was a warmer, wetter place than it is today. The rover's spirit and opportunity have found rocks and minerals that could only have formed in the presence of water. That means Mars must once have had an atmosphere dense enough to trap the heat of the sun like a greenhouse and create enough atmospheric pressure to keep liquid water stable at the surface. Conditions that could have been suitable for life. This was more than 3.5 billion years ago, when the solar system was young. Mars was still hot inside, and volcanoes pumped carbon dioxide into the atmosphere. Comets and asteroids pummeled the surface, heating and thickening the atmosphere even more. Closer to the sun, Venus and Earth started out the same way, but only Earth remains habitable today. Its hot interior and dynamic surface continuously recycle atmospheric gases, while living things maintain the mix of oxygen and nitrogen suitable for life, with enough greenhouse effect to keep the planet warm, but not too warm. This delicate balancing act of biology and geology sustains our biosphere today. Venus wasn't so lucky. Closer to the sun, it turned into a runaway greenhouse. Its early oceans boiled away, leaving a world that's been baked dry. The atmosphere is 90 times denser than Earth's, almost pure carbon dioxide, and the surface temperature is close to 900 degrees.